Okay, everybody, as we proceed into Algebra 2, we are going to start in Chapter 2 with relations and functions. It's important that today you learn the difference between a relation and a function, and that we'll learn how to graph them, and we'll learn what they look like on an XY axis. Let's start with the vocab. A relation is a set of ordered pairs with input values and output values. So input values and output values. I'll try to keep my left hand out of the way. The domain, those are the input values, which are the x values, and the range are the output values, which are the y values. In order for a relation to become a function, each element in the domain must correspond to one and only one element in the range. So not all relations are functions, but all functions are relations. The vertical line test, we run it through a graph, and so the vertical line, it passes through an XY graph. I'll just put a graph down. If the vertical line only touches once, it passes the vertical line. Therefore, it is a function. A function rule is just a notation that represents an output value in terms of its input value. So notation. Function notation is a fancy way of writing y equals. Function notation, by the way, is f of x. You've seen this in Algebra 1. So if you have f of x equals x plus 5, that's the same thing as having y equals x plus 5. The independent variable, this is hard sometimes, the independent value, that's what happens first. So I'm going to write happens first. It's typically what you would plug in. Typically. The dependent variable is what happens as a result. Happens as a result. That's typically what you get out. We'll talk more about these. Sometimes you can have a situation, for example, maybe your age and your height. What determines what? Well, typically, your age will determine your height. So your age would be the independent, and your height would depend on how old you are. In this next example, it's an example on skydiving. It says when skydivers jump out of an airplane, they experience free fall. The photos, these photos over here, show the various heights of a skydiver at different times during this free fall, ignoring air resistance. How can you represent this relation in 4 different ways? So over here you can see at 0 seconds, that's how high up in the air he is. At 4 seconds, that's how high up in the air he is. 8 seconds, 12 seconds, and 16 seconds. Now what we're going to do is represent this in 4 different ways. The first way is a mapping diagram, where you put the domain on the left and the outputs on the right. So at 0 seconds, he was at 10,000. Notice the arrow points at the output. That's really important that you have your arrows pointing the right way and that you always order them least to greatest. It just so happens that, so sometimes your arrows can go like crooked over here. They don't always have to go straight across. But 0 would have to match with whatever it was paired with. So it just so happens that it pairs with that. So just make sure you have an order to these. 4 gets paired with 9,744. 8 gets paired with 8,976. And 12 gets paired with 7,000, if you look below, 7,696. And last, 16 gets paired with 5,904. Okay? Typically, we do like to write these in least to greatest. For whatever reason, the book wrote this side in greatest to least, but from now on, I want you to write them in least to greatest and just kind of switch your arrows around. So that's called a mapping diagram. The second way to represent them is simply as ordered pairs, probably something you're a little more familiar with, and I think you can follow along with those ones. The third way to represent them is using a table of values. The table of values, just make sure your x's go in order, like 0 through 16, and then their corresponding values go beside them. And the third way is representing them using a graph. And in this particular example, you just have to make sure you pick and see how they skip evenly. So maybe you want to write that on your graph. You have to skip evenly. Okay, and you see this little mark right here? That it's like almost like a zigzag. It tells you, hey, I'm skipping a whole bunch. So I'm not going from 0 to 5,000. I'm starting at 0, I'm skipping a whole bunch, and I'm starting really my graph at 5,000. And then the corresponding points just get plotted. So the fourth way is using a graph. If you flip over, you can take a look at the got it. Now they ask us to take a look at the monthly average water temperatures in the Gulf of Mexico and Key West, Florida, and they're going to tell us that varies during the year. In January, the average temperature is 69 degrees. In February, the temperature is 70, getting a little warmer. In March, the temperature goes to 75, and in April, the temperature goes to 78. How can you represent this relation in 4 different ways? Well, first you would do a mapping, then an ordered pair, then a table of values, and then a graph. So if you want to take some time, pause the video. Why don't you try doing the mapping first? When you're ready, hit play on the video and see if your mapping is correct. If your mapping is not correct, pause the video and fix it. Your mapping should look like my mapping, having the inputs on the left, the outputs on the right. January, February, March, and April. This is what does the affecting. Determining what month it is will help you determine the temperature. So you start at the month, you go towards the temperature. Again, these are the inputs because these items do the affecting and it determines what the temperature will be. If you didn't get that right, pause the video and try it again. Fix it according to what it looks like on mine. The next thing you're going to do is do the ordered pairs. Again, do the same thing. Pause the video, make your ordered pairs, and then push play when you're ready to check your ordered pairs. Okay, check out your ordered pairs. See if you got your X and your Y values correct. Remember, independent are your X's, dependent are your Y's. Now let's try the table. Flip back over if you need to try to make your table look nice. Pause the video, try it on your own, because when you start the video again, my table is going to be done. Right, looking at the table, how did you do? One thing that I would think that maybe some students might miss are the titles of month and temperature. Maybe you only did January, February, March, April, and you forgot your title. If you did, just take a moment and put the titles on the top. All right, one last thing is the graph, and I'm going to do this on the video with you. To me, the graph is the hardest thing because you have to, and you really should, use a ruler to make your axes because a graph should be as nice as possible. You're only going to have one of these on your homework tonight because they do take a little bit of your time, all right? Now, over here, or excuse me, down here, we're going to have our months. The independent goes on the bottom, and over here we'll have the temps because the dependent goes up the axis. I'm going to notice that my smallest temperature is 69. So I'm going to use a little skipping sign. It almost looks like a Z. That indicates that you're skipping. And I am going to start at 60. I am going to skip by 5s. 65, 70, 75, 80. That's going to make a nice chart. Make sure you space it out pretty evenly. On the bottom, I'm going to have January, February, March, and April. Now I'm just going to plot my points. January is 69, so very, 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 very close to 70. February is 70, so that will be right at 70, just a little bit higher. March will be at 75. And April will be very close to 80 because it is 78. And now you have a nice looking graph of the temperatures. In problem 2, I'm going to teach you how to find the domain and range. Be very careful to write them the exact same way that I do. So we have this relation. A relation, by the way, is just a whole bunch of points. So let's see, I have 1, 2, 3, 4, 5 points. It says what is the domain and what is the range. And then put a little extra note in here. Please make sure to put them in order from lowest to highest. Okay, so let's start with the domain. I'll just write a D with a colon and then a brace. So the domain are the x values, don't forget that. So we're going to put them in order least to greatest. So I have 0, 4, 8, 12, and 16. And they're already in order for us, which is really nice. And then we finish it with a brace. Now we'll do the same for the range. Write a capital R. Remember the range are the y values. And now we're just going to put those ones in order. Use a brace. So the lowest one I see is 5,904. And then the next lowest is 7,696. And then 8,976. And 9,744. Notice we're putting them in order. And 10,000. Also, make a note to put them in order. Let's put another note up here. Don't repeat. So if a number happens twice, you don't put it in your domain and range twice. So don't repeat.